So the outline for this talk is just 3 basic sections. We're going to talk a little bit about the context of what it means to be a content scientist versus a statistician and what those different roles are about. We're going to talk about writing the approach section for an NIH style application, including writing a narrative analysis plan. Those 2 parts are in this talk, and then part 3 is going to be a separate recording about creating a code book and really getting to know your measures and your data. So the context for this really is the overlap between statistics and content science. And for the life of me, for many years, I've been searching to reproduce this article that I read a long time ago that had this line in it: "I'm a statistician, mind if I operate on your brain?" And the idea was sort of, to what extent are the statisticians and the content scientists expected to know each other's business, right? So if, let's say, you're a diabetes researcher, or you're an intervention scientist, or you're an implementation scientist, are you also expected to be a statistician? And likewise, how much of your content science do I need to know as your statistician? It's a tricky question. It's not a question that I have an answer to. But I will say that you're always going to need a statistician. And that person may call themselves a statistician or a biostatistician or a research methodologist. But you are going to need to collaborate with someone who has spent their career really reading about and staying abreast of emerging methods and the nuances of research design. And I also want to say here that I'm not going to call them competing fields, but different fields of study call the same things different things. And I just was having a conversation with someone recently about covariate identification, which if you come up in a biomedical, nursing, health services setting, you might think about statistical modeling. And if you don't know enough about it at this point for this to make sense to you, that's okay, you will soon. But the idea is, like, what variables should be included in my model? And how do I make those decisions? And we call that in my business sort of covariate selection, or you know, it's sort of generating a conceptual model for your research question, right? What are the important things in my model? What are the important predictors of my outcome? And then in machine learning, they might call that same process the creation of a directed acyclic graph. And you might not know that, I might not know that. I just learned that. That's something that I've been doing for a long time in the context of structural equation modeling. In different fields, they call a completely different thing. So, you know, methodologists and statisticians are in their own little niches, like we all are, and they come from their own training traditions, like we all do, and speak their own language, like we all do. And sometimes it's difficult to figure out, you know, who's doing what. And that's why you need someone in the middle, right? A methodologist, a statistician, to try to even translate those kinds of distinctions back and forth for you. I also want to say that research design, thinking, and by research design, I don't mean naming a specific research design, like this is a randomized control trial. I mean thinking deeply about issues of inference. What is the best inference I can get out of this study? That we generally like to say that design trumps analysis, right? And there's a beautiful quote at the top of this slide from a trio or a duo, Willett and Singer, who said, "You cannot fix by analysis what you bungled by design." So sort of making the point, which I will be making in the subsequent slides, that the statistical analysis plan is really the least important part of a research proposal. And your analysis plan doesn't exist in a vacuum, right? It's part of your overall approach and research plan. It's always in service of questions that you have thought through, that are theoretically motivated, for which you have a robust and clearly demonstrated conceptual model. And then at the very end of that, right, we get to writing an analysis plan that performs some statistical tests. And the reason I'm saying this is because learners and trainees tend to be nervous about statistics. And I think the reason they're nervous about statistics is because they're nervous really about the other stuff, right? Doing science is hard. articulating a good question that is novel and grounded in the literature in your area, coming up with hypotheses, designing a study. And I will tell you now that the study that you design is always the best study that you can afford. If we are in the business of intervening on people for the purposes of producing some desired outcome, then the best study that we could possibly ever want to do, right, is a perfectly designed, prospective, randomized control trial where we have strict control over all kinds of things, thus increasing the internal validity of the study, right? In our business, generally speaking, most of us are going to want to do an intervention at some point or want to think about how programs or interventions might impact the populations that we care about, and we would all want to be doing RCTs, right? But it's very hard to afford an RCT. And often the literature doesn't support an RCT in a particular area, right? The evidence continuum is not yet at a point where an RCT is warranted. RCTs are hard to do and expensive. And so we are always designing the best study we can afford. In some cases, you might try to answer the same question about the effects of an intervention in completely retrospective data. Those are called retrospective, sometimes comparative analysis or comparative effectiveness questions, right? So as trainees, as new scientists coming up, we often can't afford a large RCT, and we're trying to just design the best study we can afford. And then the next thing that we're going to spend a lot of time talking about is deciding which variables to measure and how to best measure them. And then we're going to really think deeply about, given the best study that I know I can afford and the number of people that I can afford to enroll and what the state of the evidence is in this area, then I have to sit down and think really closely about what results might my study yield? What's the best inference that I'm going to be able to get out of my study? Given the variables that I have access to, or the variables that I propose to measure, what kinds of distributions might they have? How might they be related to each other? You know, what's the average on this variable in the population, you know, that's already out there in the literature, right? All of those things go into and happen before we ever think about performing a statistical test. So all of that is the context for this talk. And a few takeaways I think from that are, there are always new statistical models emerging, and people are sort of jealously guarding them in different fields of study and calling them different things. And that probably will never be your job to know how to do that. If you are able to do the other things on this slide, really know the variables, know what the numbers mean, where they come from, and think about likely study results just in plain English, and understand sort of what it takes to design a good study in the setting that you're in and with the budget that you have, and especially to understand kind of the evidence continuum, right? Where is your research area in terms of the evidence that already has been generated, right? Where along the evidence continuum is it? All of those things are the things that the content scientists know how to do. And then at the very last, you get together with your statistician and you say, I'm interested in understanding the relationship between this and that, or the effect of this or that. And that's where your statistician will work with you to sort of figure out what are the statistical tests that need to happen. Okay, so having said all of that, we're going to talk a little bit about what it means to articulate your question well enough that you can then write a narrative analysis plan. And we're going to motivate that with an example. So all a narrative analysis plan is just your articulation of your research questions in plain language. And I say that because writing an analysis plan is really simple. All analysis plans have the same basic structure. They're embedded generally in an approach section. And I have some examples of different approach section formats that I had access to share with you. And then the section in the approach that talks about the statistical analysis, right, presents each analysis along with the question that it answers in a progression that makes sense and that then is mapped absolutely in the results section. The Results are presented in the exact same order that they were presented in the approach, and nothing is presented in the results section that wasn't introduced in the method or the approach section. This actually, applies also and was generated by thinking about writing an article after you had already collected some data, but the same principles apply for writing a proposal. So here's some examples of approach sections. So there are 4 of them here. What I did was went back to 4 submissions that I had been a part of and pulled just the headings out of the approach section. So this is what was an NIH R21. The larger heading is at the top, approach, and then you can see the way the approach section was structured. The first heading was setting and research design. Aim 1, recruitment and quantitative data collection, and then there was a table. This particular project was about social determinants of health. Then there was Aim 2, quantitative analyses, and that led off with the sentence, literally, our overall goal for quantitative analyses. Then there was a table of variables, a data management plan, a section for data screening and preparation, a section for missing data, and then Aim 2, quantitative analyses, and then Aim 3, which was a qualitative aim. So you can just see a general structure. Everything that you need to tell your reviewer about what you're going to do, right, and how you're going to do it is in here. But it's, the format is not, there's no pre-specified format that has to be used. So let's look at the next one. So the second one, it was an NIH R01 that was funded. That's what that little asterisk means. And you can see that it's entirely different and has a simpler general layout, right? It starts with the words research approach, presents, literally the first sentence of the approach section was the conceptual model is presented. Then there was a big section about the intervention. Oh, this is an intervention study, overview, development, preliminary data. Then Aim 1, setting, procedures. The procedures included the statistical analysis plan, and then potential pitfalls and contingency plans, and then the same layout for, somewhat same layout for Aim 2. I'm just motivating here the idea that the approach section can have a number of different formats that work for your particular project and that will include an analysis plan. Here's another one. This was an R03. Under the word approach, literally the first heading was proposed study overview, research design, inclusion, exclusion. Aim 1, articulated, expected outcomes. Aim 2, outcomes. And again, you'll see all of these have a section that says, I've thought about what might go wrong and what I'm going to do if something does go wrong. And then a plan for data management and analysis, a general plan, power and sample size, descriptive analyses, and then the statistical proposals for the aims separately. So different format, right? None of these are better or worse than any of the others. And then here's the final one. This was a funded project that I worked on quite a while ago, and I like this one because, again, it uses under the larger heading of approach, a section of overall approach where the study design is articulated. And literally the sentence, the first sentence is a PICO statement, which we're going to look at on the next slide. So under overall approach was population, sites, enrollment, a description of the intervention, and then the specific aims. And I've only listed one of them here. Again, I listed it because it is articulated as a PICO question. Then there was outcomes assessment, data collection, data management, and data analysis. And that data analysis piece in all 4 of these, right, was just a small portion of the overall approach section. So I hope that those would be useful to you to see some examples of what some real approach sections have looked like. So as I said, all analysis plans, and that is only a subset of the approach section, remember, have the same basic structure. You're going to talk about how you're going to screen your data after it's collected, how you're going to analyze whether there's significant missing data, how you're going to do a visual inspection of the distributions of variables. You are going to compute descriptive statistics. Of course you are. You're going to look at your sample and subgroups if that's a part of your study. You're going to compare those values to normative values if they're available. What I mean when I say that is if you collect a standardized measure, like a depression inventory or a stress inventory or an adherence or activation measure, right, a measure that is already in the literature that has been validated, then there is going to be some data out there published that talks about what kinds of values other populations of patients have. And it's a nice idea to compare your sample to normative values if they're available. You're going to look at the interrelationships among all the variables that you collected. You're going to have a big table that literally has every single variable that you've collected, your demographic variables, any clinical or variables that you might have access to, the primary predictors and outcomes of your study, whatever they are. You're going to look at all interrelationships, and then you're going to do the statistical analyses that are driven by your hypotheses or the hypothesis tests that are necessary for the aims of your study. So here's an example. This is an analysis plan that literally goes in exactly that same format that I just talked about: data management, missing data, descriptive analyses, and statistical analyses for the aims. Just like the approach sections we looked at, this might be different depending on how your particular approach section is structured and the nature of your project. You might break out the analysis plan for the aims separately. Or you might put them all together if they're the same. So you can see at the bottom of this page, it says generalized linear mixed effects modeling to answer the question of differential change over time between treatment groups. So this is a pretty standard approach for a study where you want to contrast treatments to each other and you have multiple time points. I hope that I've convinced you that all analysis plans have the same basic structure. They do. And that's the easy part, and that's sort of the part that you might have some templates available to you that you could look at, and you certainly will have a statistician to help you work with on that kind of stuff. This is the easy part of the approach section. Okay, so let's undertake I want to introduce an example to you guys to motivate what it means to really be able to write a narrative analysis plan. And the example that we're going to use is we're going to pretend that we have a mindfulness-based intervention that we think has an impact on recovery from alcohol use disorder. And you were able to look at 15 patients in a pre-post pilot, and now you have money perhaps to implement a randomized control trial at 10 different sites, and you're going to measure at baseline 3 and 9 months. If you are ever in a position to propose a pre and post RCT, so you are going to randomize and you are able to collect data at least twice, always try to get it more than twice. And that's just a nice rule of thumb, right? If it's worth it to you to try to understand how people are changing over time, right, the effect of the intervention, then it's probably worth asking whether or not there is the intervention can be sustained at an additional time point. That's one of those trade-offs that I was talking about in terms of research design being the best design that we can afford. But in general, if your research question, your intervention, your treatment, whatever it is far enough along the evidence continuum to be proposing an RCT or to be implementing an RCT, and you have the money to do it and you have the patients, it's hard to get patients enrolled in a trial. It's hard to do all of these measures, right? It's hard to get them to go to an intervention and be adherent to it. And it's so expensive and so difficult to conduct a study like that. So if it's, think about the sort of cost benefit of after you've already done that, is it worth the extra work to try to get everyone to come back in for an additional time point? And the answer to that question is almost always yes. But I digress a little bit about that. So the first thing we're going to pay attention to is the thinking about this intervention. The way I phrased this research question was, what is the effect of a mindfulness-based intervention on recovery from alcohol use disorder? How do we like that as a research question? Have we framed that well? Is there a PICO question in there? So if you guys have not learned the PICO format or the PICOT format, that might be just, some traditions, some sort of academic traditions teach it and some don't, but it's a pretty useful thing if anything that you're ever going to do is going to involve intervention. So I know some of the students in this cohort, right, you guys you're new, you're learning your field, you're learning your area, but probably, and I've made this point pretty often about research in general, there's probably an intervention implied somewhere in the work that you do. This dawned on me late when I was studying childhood adversity. Like, what are the impacts of childhood adversity on adult health outcomes? I got to thinking long and hard about why would I study this question in isolation, and realized at its core, right, the idea might eventually be, not me, but this research field, to design some sort of a treatment to intervene, right? If I know that this predictor or this exposure has an impact, wouldn't I eventually, or wouldn't people in my area eventually want to try to intervene on it? And so I think if we think about it like that, then probably in your research question or in your research area, even if you're not doing it yourself now, there is an intervention implied somewhere. So let's try to look at the PICO format. PICO stands for Population, Intervention, Comparator, and Outcome. And many health sciences and health services research questions can be effectively phrased this way. So, have I done a good job with my research question? What is the effect of a mindfulness-based intervention? That's the intervention. Compared to, right? I need a comparator. And this is something that the PICO format helps us remember, is that if we're doing an intervention in a particular, right, we're doing an intervention, we have to compare the group of people who get the intervention to someone, right, to a comparator group. We want to be able to identify the population that we care about, and we want to be able to identify the outcome that we care about. So that's all the PICO is. I don't want to go back in the slides, but I will invite you to go back and look at the fourth example of the approach section that I showed you, which was a funded study that literally embedded that sort of PICO format right at the top of the approach section and right in the articulation of the specific aim. And it's a nice habit to get into. Okay, so this is part A of our small example. This is, let's just imagine we did have that pre-post data about our mindfulness-based intervention. What kinds of questions can we ask, right? What is some plain language articulation of research questions that are possible here? How about A? Is A a question that we can ask here? A is not a question that we can ask here because we don't have two groups, do we? We have a pre-post study. How about B? Is there a difference between the time points? Are B and C identical? Is there a statistically significant difference between pre and post scores? Are A, B, and C, or I'm sorry, are B, C, and D identical, right? Asking if there was improvement over time, is that identical to asking if there's a statistically significant difference between the time points and or asking if there's a statistically significant mean difference between pre and post scores? So B, C, and D are all sort of variations of the same question, and they're all reasonable. D, statistically, would correspond to a slightly different method, right? Because it's asking only about improvement and not about change or difference. But nonetheless, those are all about the same question. How about E? Is there a statistically significant difference in the proportion of patients at each time point with clinically meaningful recovery? Is E the same as B, C, and or D? But even though B, C, and D are all generally restatements of the same question, E is not. E is a completely different research question. And it has to do with the difference between recovery versus just change in scores on some measure. Those are very different things. And only you would know if this research area was far enough along to, ask one question versus another. You have to know, which we'll talk about in the next part, you have to know the measure that you're using to assess change, how sensitive it is. And you would have to know, as a scientist, presumably studying alcohol use disorder, whether or not it was meaningful for scores on that measure to improve by 2 points versus, just marking someone as having clinically meaningful recovery or not. And those questions imply different statistical tests. And then F is also sort of related to E in terms of asking about the percent of patients versus the proportion of patients. So these are different questions is sort of what I'm motivating. And this is just a simple pre-post, right? So this is when I talk about being able to articulate your statistical questions in plain English, this is what I'm talking about. So that was the easy example. Let's think about the more difficult version of this, which is you now have data from a randomized control trial at 10 different sites and 3 measurement points. What kinds of questions can be asked here? And before I advance the slide with the bullets on it, I'm just going to give us some time to think about this. This kind of a design where you have a randomization to group and you have more than one time point as a classic clinical trial design. Some people call it a split plot. Split plot is a common way to term this design if there are only 2 time points. And as I said before, if you can afford more than 2 time points, you should always collect them. What kinds of questions do you want to know in this kind of a design? Is it important to know if there's a difference between the groups at baseline? If you have a well-conducted, truly randomized trial, the answer to this question should be no, right? There shouldn't be a difference between your groups at baseline on any important demographic or predictor variables, and especially not on anything having to do with the outcome. But you do want to know the answer to that question, right? And you want to be able to articulate that you know that that's an important question to ask because it speaks to the quality of randomization. Okay, let's look at a few more. So we could certainly ask if there's a difference between the groups at 3 months. So this is like saying, I randomized them. I figured out that they were all the same to begin with, which is an important feature. And now I've implemented my intervention and I have a post-treatment measure. Is it important to ask if there's a difference between the groups at 3 months? How about at 9 months? How about on average post-treatment versus pre-treatment? How about at either and any and all of the time points? How about we start asking about improvement? And I want you guys to think carefully about the fact that asking about whether or not the groups are different at 3 months, or asking if the groups are different at 9 months, given that I know that they weren't different at baseline, is not the same question as asking if they changed. This is subtle, but I use this example because I've run across it many, many times in real world studies where investigators come to me and say, I've implemented my intervention. I want to know if there's post-treatment differences. And I say, well, if you're only looking at post-treatment scores, right, why did you bother to measure them at baseline? Right? Or why do we have that baseline data? Yes, I assessed whether or not randomization was successful by examining them pre-treatment. Now, do I just want to look at them post-treatment, or do I want to know about change? Those are different questions. Again, there's the issue of improvement. Maybe I want to know if in my model, my statistical modeling of change, what the rate of change is. And if I want to know what the rate of change is, maybe I can ask whether there are features about the patients that predict rate of change or predict change. These are all questions about change and rates of change versus questions about between group differences. And as I said, I bring that up simply because this is a very, very common big conceptual divide, because if you decide you're going to ask questions about change, you can't then go back and ask just post-treatment between group difference questions. If you ask just post-treatment between group difference questions and maybe there aren't any differences, you can't then go back and say, oh, you know what, instead I'm going to model change. Those are very different things. Because we have a site here, I just threw this one in, right? We might ask about site differences in response. We might ask about the interaction of site and patient level features on response. And you, right, you've designed this study. And so when I talk about the narrative articulation of your research questions, this is what I mean. You decide the questions you want to ask, and then you collaborate with your statistician to figure out the best way to model the answers to those questions. That is the end of this part. even in what seems like very simple study designs, there are many questions that can be answered. I hope that the take-home message here is that writing an analysis plan is relatively straightforward. You know now the elements that need to be in there in terms of data screening and data management and missing values and descriptive statistics, and you know, or maybe hopefully feel like you have a handle on what it would mean to sort of articulate the research questions that you're trying to ask in plain English. And in the next section, we'll talk about developing a code book.